Very good morning. Today we are going to see the difference between standard and non-standard DH representation. Because last two classes we were talking about DH representation, and I gave a distinct, you can say distinct difference between these two. Still, I felt you may require little more attention on that. So I just wanted to make sure that you are actually like understood. So for that, I'm taking a two link. In the sense, I would be seeing three joints. Can we actually like see that? So this is so the first link. So this is the first link, and in order to make it the other clarity, so I'm just taking this as the second link. So in the sense, the first link axis will go like this, and the second link axis will go like this. So in the sense, probably in order to make it a little more clear, so I'll just make it second link little you call so in the sense it is a little inclined. Okay, so this what the case. So now you can see that the link you can see this is a link k minus 1 and this is link k. So in the sense this joint is actually like this is z I minus 1 and this is z I and this is z I plus 1. Okay, so now you can see that immediately what we will do, we will do a common normal between these two, and that is the axis of xi minus 1, and we'll make a common normal between these two, and that is what you call xi axis. So now you can see that the xi minus 1 and the xi is actually like having a different distinct, in the sense there is an angle apart, so then we will actually like see it. So this is the way we are actually like trying to see. But what is the standard representation or standard thing? So that you can see this is what the case. So now, so what this angle which is actually like between xi minus 1 and xi, so this angle we would be rotating about zi, so that is we call theta I, and you can see that this is what the frame of I minus 1, and in fact for standard form, so they will bring it here. So this is what I minus 1 frame, in the sense what standard form will see from the joint axis zi and see how other axes are actually like going on. So in the sense the first two joint parameter would see with respect to the previous frame, and the next two, which is actually link parameter, would be seeing the progressing side. That is the basic difference between the standard. So I'll just make it little more clear on that. So I'll just show you that this is zi minus 1, and okay, so this is zi. I assume that this is zi plus 1. Okay, so now you can see that this is what you call the common normal between these two, and I assume that this is the common normal between these two. So in the sense I can actually like draw the x-axis in red color. So this is xi minus 1, in the sense it goes like this. Okay, and this is what your xi. So I'm just showing the parallel line to xi. So now I will rotate about theta, like theta I angle, that is what I call the joint parameter. So the first one is actually like your rotation angle, in the sense I am trying to see, so this I minus 1 frame, try to make it parallel to xi, and I am actually like moving it further. Okay, So now I will do the second operation. The third operation, what I will do, I will actually like make it, this is, okay, this is the zi plus 1. I am actually like making it parallel. So this is parallel, so zi plus 1. And now the angle which is actually like, now the angle which is about this xi, I am rotating and making it parallel. This is what I call alpha I. And along the xi and try to reach I to I plus 1, that is what I call ai. Okay, so now you can see that what operation we did. First we did rz theta I, okay, then dz di. Then what we did actually like the rotation about or along alpha I, and then translation along ai. Okay, so this is what we can see. But here, as per this case, this is link I minus, this is link I, and this is link I minus 1. So this is you call transformation matrix. So transformation matrix of, you call, this is I plus 1 to I. Okay, this is the original notation we supposed to follow. But what most of the standard textbook will see, so the point which is we started, so that is the point we assume. This is, so they will actually like bring it, this is link, you can say k I minus 2 or I2, and this is link I. So then they say that the link I minus 2 will have I minus 1 here and here. So in the sense, this joint what we were seeing, that is at I minus 1, okay, and this is actually like xi minus 1, like that they will keep going. So in the sense, you can see that then the same thing we can write in the previous coordinate. In the sense, the same thing we can write as I minus 1 and I. So this is what you would have seen in the previous lecture. But this is the original aspect. So you no need to confuse. So you can see that what we are seeing in the standard form, we are actually like seeing the joint parameter with respect to previous joint. Okay, in the sense, we are actually like seeing with respect to link. So I'll keep it. So this is a link I minus 1. And this is link I. Okay, so that way we will actually keep it. So then what you can see, so the first two join variable, that would be referring to the link I minus 1 to link I, and the two other parameter we will not see from here because we are actually like standing on ith axis. We are standing on ith axis and we will actually like progress with the ith axis itself. So that is the basic difference. So that is what we call standard form. So now you can actually like see what are the operations we have done. So the first operation, we have done the rotation about z axis. So that is actually like cos theta I minus sin theta I, and 0 1, and sin theta I and cos theta I 0 0, sorry 0, so 0. So this is the first operation we did. Okay, so now the second operation what we did, dz di. So that is you can say rotation matrix is 1, which is identity, and then we have translated along zi. So that is what happening. So I am actually like multiplying these two just for my own benefit, so that I can actually like do the two other operation. So what will come, this is actually like cos theta I, because this is what the row and column, so that would give only cos theta I. Then the second, you can say first row and second column, that would give minus sin theta I. And you can see this first row third column would give 0. First row and fourth column also 0. Then the second row first column would give sin theta I. Okay, then we'll actually like make it further. So the second row second column would be giving cos theta I, and like that we can go again. And third row first column would be 0, then this is also 0, 1, and this would be giving theta I, and this is the way it goes, right? So now the similar way, the other two operation what we did Rx, you can say alpha I. So in the sense, sorry. And the next operation what we did, translation along x as ai. So now this is what we are maintaining. So okay, so now what this matrix multiplication will give, you can see like first row first column is 1, and first row second column is 0, first row third column is 0, first row fourth column is ai, and the second row first column becomes 0, second row second column would be cos alpha I, second row third column would be minus sin alpha I, and similarly it is 0. Like that you can actually like go again. Right, so these are the things we'll get. So now what we have done actually like so r z theta I, we are actually trying to find out I plus 1 to I, then d z di, and rx you can say alpha I, and dz you can say theta, sorry, ai. Okay, so now you got this matrix, you already multiply, and this you have already. So in the sense, this is actually like cos theta I minus sin theta I, and 0 0, then sin theta I cos theta I, 0 0, then 0 0 1, and di, and 0 0 0 1. Here actually like you can see, so this is a 1 0 0 ai, and this is 0 cos alpha I, and sin alpha I, 0 minus sign is here, 0 sin alpha I, cos alpha I, 0 0 0 0 1. So now you multiply what you are getting, that is what nothing but your matrix. So in this case, first row first column you can see it is straightforward cos theta I, first row second column what would come, so that would be actually like multiply sine, in the sense it is cos alpha I sin theta I, and minus sine. That is right, because first row second column this term and this term would be multiplied. Similarly, first row third column would be minus of minus, so it would be sin alpha I sin theta I, and the fourth one you can see ai cos theta I, that is what remaining. Okay, so now similarly you go, the second row first column would be sin theta I, and what happened to the second row second column, that would be cos alpha I and cos theta I, and second row third column would be minus sine, so minus sine alpha I and cos theta I, and what is the fourth one, so that would be ai sin theta I, right? And we go further, so the third row and first column would be 0, third row then you can see second column, that would be sine alpha I, and the third row say third column, that would be cos alpha I, and third row fourth column would be, you can see di, and the remaining is actually like this. So now this is what the ARM matrix based on the you call what you call standard form. Okay, so this is most of the textbook would be written like this. So in the sense what they start with the, you can say joint frame with 1 not 0. If somebody start with the 0, then there is a confusion will come, but if you start with the joint axis 1, then this is the form, and this is what most of the textbook would be written. For example, if you see Professor S.K. Saga's book, this would be written in this way. So this is what you can see the standard form. What we did, so we take this way. So this is, we assume the ith frame, and this is I plus 1 frame, and this is actually like I minus 1 frame, and we assume that we are interested to see the I plus 1 frame with respect to I, in the sense you need to know the information of this two, and you need to know the information of the, you can say, transformation. So in the sense, we assume that this part, whatever this is what actually like compress, in the sense we start from the joint 1 and then we go. So in the sense we will actually like progress in that aspect. So that is what we are actually trying to do. So you can see this is what one such case. Okay, so this is link I, link K in this case. So we'll actually like go the same way to the non-standard form. So what non-standard form did? So non-standard form actually like start from the I minus 1 frame. Okay, so then you can see, so this is I. So this is Zi and this is Zi minus 1. And what we know, so we know further the xi direction, and in this case we will not see actually like the I plus 1 frame at all. So what we will see the link K minus 1 or I minus 1, whatever you can see. So that would be having I minus 1 frame and ith frame, and we will see only the xi direction. So in that sense we will draw a common normal, and we will identify what is xi minus 1. So then you can see that the xi minus 1 is the first operation we will do. We'll make it parallel to zi and we'll rotate that. So that is what alpha I minus 1. Then we will actually like travel along this. So we will hit here. So this is what you call ai minus 1. Then you will see that your xi minus 1 is still here, and this is what parallel to xi, and there is a theta I operation will do, because we are going to rotate about this, and then we will actually like translate along this. Okay, so in this case what we are doing, we are actually like rotate, so alpha I minus 1, then translate ai minus 1, then rotate you see theta I and translate, you can say di. Okay, so this is going to be I minus 1. Okay, so this is the transformation matrix. Already we know this multiple, so we'll bring that. So in the sense what we are doing, so we are actually like interested to find this, and we are taking the two, so multiplication. So this is actually like going to be x multiplication. So then this would be look like this, alpha I minus 1, this is sine alpha minus 1, this is going to be ai minus 1, 0, 0, 1, and this is cos alpha I minus 1, this is sine alpha I minus 1, and this is 0, 0, 0, 0. Okay, here what will happen, this is cos theta I minus sine theta I, and this is 0, 0, sine theta I, cos theta I, 0, 0. So 0, 0, 1 di and 0, 0, 1. Okay, so these are the things will come. So now you can actually like see, we will multiply these two, and what matrix will come. So that is what we are actually like interested. So that multiplication I am putting here just for my own understanding. So the first row, first column, what will come? So that is simply cos theta I. Okay, first row, second column will give minus sine theta I, right? So first row, third column would be, you can see nothing, so 0. First row, fourth column, you can see, so this is giving 0 di, and you can see that is ai minus 1. Okay, so now we'll come back to the second row, first column. So second row, first column, what will come? So this multiply with this. So in the sense cos alpha I minus 1 sine theta I, right? So then nothing else will come. Then the second row, second column, So you can see cos alpha and cos theta. So in the sense cos alpha I minus 1 and cos theta I. And third row, you can see that what you can see, this is, sorry, this is a minus sign, right? So third row, what you can see, this second row and third column, you can see minus sine alpha I. And the same thing you multiply, what happened, the fourth element, that would be minus di, okay, sine alpha I. Okay, the same thing you go for the third row element. So in the sense, third row first element would be, you can see, third row first element would be sine alpha I minus 1 sine theta I, and the next element is actually like sine alpha I minus 1 and cos theta I, and here you can see it is cos alpha, so this is cos alpha I minus 1, this is di cos alpha I minus 1, and this is 1 and 0 0 0. So in the sense, you can see, so the t I minus 1 to I is nothing but this way. So this is cos theta I minus sine theta I 0, then this is a I minus 1. Here what you get, you can say cos alpha I minus 1 sine theta I, and this is cos alpha I minus 1 cos theta I, and here minus sine alpha I minus 1, and this is minus di sine alpha I minus 1, and this is di cos alpha I minus 1, and this is cos alpha I minus 1. So here you can see, so here actually like instead of this, that would be sine alpha. So cos alpha I minus 1, sine alpha minus 1 cos theta I, and this is sine alpha I minus 1 sine theta I, and this is 0 0 1. Okay, so this is the difference between you call standard and non-standard. You can see the standard would be everything in terms of I, whereas non-standard you can see that mixed of I minus 1 and I, that is the basic difference. But you can actually like easily cross check. So this is the easiest way. When you see that, so these two frames are parallel, but it is having a distance apart. So what happened? So a I minus 1 and d I r would be the you can say the position vectors. So in the sense a I minus 1 d 0 d I, and this would be identity matrix. Can we check that is happening or not? Both are parallel, but it is actually like distance apart. So it is easy. So this is I minus 1 frame and this is I frame. What happens? So alpha I minus 1 is 0 and theta also like 0, right? So if you substitute, this become 1, this becomes 0, 0, a I minus 1 remain. This is 1 and 0, this is 1 and 1, 1. So this is 0 and this is 0, and this is you can say 0, 0. So 0, 1, this is also 0. So this is 1 and this is 1. Okay, so this is 1 and multiply with di, so di would be there. So you can see this is up 10, right? So now you can see that there is no distance, but you have actually like something. For example, I say you can see this is what your zi and this is zi minus 1. So what you can see, so you can see that the theta I would be 0 still. So both xi and xi minus 1 are same, but you can see that only alpha angle, that you can see in the sense what happened to the rotation matrix. The zi would be fall in y axis, but it is opposite y axis, right? And y axis would be coming in the what you call positive z, so that you can actually like cross check. So in the sense you substitute, this is 0, this is 1 0, and you can see this is a would be 0, and here what happened, alpha is 90, so this becomes 0. This is actually like become 0, and you can see it is minus 1. In the sense the z axis is actually like on the minus y direction, and you can see that this would be 0 and this would be 1 multiplied with 1, so that would be 1. In the sense that is the positive, you can say z axis direction, but it is actually like y axis, and this is 0 and this is 0. So like that you can cross check and you can get it. So this is the way we can actually like differentiate your standard and non-standard form. So you got a clarity, like a standard form will be actually like looking at the joint and then it is seeing the information between two other links, whereas you can say non-standard form will actually like see you can say two joint access, in the sense it travel along the link and reach the joint. In the sense it does first to make sure that both the joints are actually like you can say parallel and collinear. After that it sees what is the distance and angle apart between these two. Okay, so this is the basic idea behind the standard and non-standard form. I hope you got clear, and we are going to use only the non-standard, so you no need to worry much. But if you are seeing in the textbook something which is actually like written in the standard form, you should not actually like get panic. So only one thing you should be very clear. So the DH parameter definitions are still same. Only thing how we are actually like carry forward from one notation to another notation is the different. Okay, when I call alpha, so alpha is actually like still if I say alpha I minus 1, the angle between zi minus 1 and zi about xi minus 1, that is same. Whether you are taking a you call standard form or non-standard form, this is the same. So similarly theta I is actually like the angle between you can see xi and xi minus 1 about zi, that is also same. Okay, so the definitions are same. Only thing the you can say notation, what you call the representation, how we are carrying forward, or how we are actually like carry forward each you can say transformation, how, that is what the difference. So with that I'm actually like closing this particular you call short session, and we'll meet with you can say frame arrangement in the next class, and we will move forward. Thank you. Bye. Take care.